This is FRQ 2015 question 1. The problem, the rate, that's a key word, of water, rainwater flows into a drain pipe is modeled by this. R for rate. Okay, they use R for rate a lot of times. In cubic feet per hour. That's going to be important. T is measured in hours from 0 to 8, so it's 8 hours worth of rainwater flowing into a drain pipe. The pipe is partially blocked, allowing the water to drain out of the other end of the pipe at a rate of D, drain out. So this is how it's draining out. This is how the rate at which it's coming in. Can you catch that? This is rate in, this is rate out, draining, D, R for rate coming in. 0 to 8 again. There are 30 cubic feet of water in the drain pipe at time 0. So for question 1, how many cubic feet, that's important, cubic feet flow into the drain pipe in 8-hour interval? So I only want what's coming into the drain pipe. So do I care about D here? I don't care what's draining out. So D is out of the picture for this problem, for this question. But does it care about what's coming in? Yes. Now R is a rate. If I want how many cubic feet, well, I am at cubic feet per hour. How do I get a rate down to an amount? Aren't we going to be integrating? Okay. So we are going to be integrating. Do I care how much is, do I care about this 30? No, that doesn't affect how much has come in. That just tells you how much was there to start with. So we don't care about the 30, and we don't care about the D. We just care about this function. And on that function, we are trying to create an integral. Okay? So we have an integral from 0 to 8, correct? Isn't that the time frame? And aren't we going to integrate the rate function, which is R of t? Don't forget dt. Won't that give us the amount of water that's flowed in? The amount of change that's happened. And this is a calculator-based problem, since it's question 1. So you use your calculator, use that function, type it in, get an answer, and your answer, you go to 3 decimal places, all right, and you're going to get 76.570 is what you should be able to get. All righty, for question 2, the amount of water in the pipe, is it increasing or decreasing at 3 hours? Give reasons. So the amount, that's key, and increasing or decreasing. So increasing, decreasing means the derivative of amount. So aren't we looking for the rates? So we're looking for a rate, positive or negative. So is the rate at which the amount is in the pipe, is that positive or negative? Is what it's saying, at 3. So let's think about this. Let's find, how do we find the amount of water increasing? Well, don't we want the rate at which it's in the pipe? Now, isn't the rate at which it's in the pipe simply going to be R of t minus, I'm going to call this actually amount. Okay, the amount in the pipe, okay? The rate of the amount in the pipe, I'm going to call A, it's not really the amount, the rate of the amount in the pipe. Isn't that going to be R of t minus D of t? Isn't the rate at which its amount is in the pipe, isn't that going to be R of t minus D of t? What's coming in minus what's going out. Won't that be how much is in it? All right. That will give you the amount change. And if we want that positive or negative, aren't we trying to see what that amount would be at 3? So don't we want to find, is R of 3 minus D of 3 positive or negative? What is it? We want to find A of 3. And is it positive or negative? That would be as if it's increasing or if it's decreasing. So how do you find this? Well, you have a calculator. Could you just simply find this with your calculator, find this with your calculator, and see what the answer is. And when you do that, if you did that, you would catch on that the answer is either positive or is it negative. And what you would do when you find the answer, you would find it's negative. What does that mean your answer is? Decreasing. So you would find that it's now decreasing. The amount of water is decreasing. Again, remember, A doesn't stand for amount. It means the rate of the amount. How we wrote this. So would it help almost to say this? What if I said A? Would that make more sense? A prime t, the amount rate, is equal to RT minus dt. And that's decreasing. Now, my reasons, you'd have to describe this. You go, okay, you'd have to describe, okay, my function, and then I have to describe, okay, this is negative, less than 0. A little bit more description. So I didn't explain that, but hopefully you got the answer of that part. We're not going to do the reasoning on that one. But on this one, from 0 to 8, the amount of water is at minimum. When I say amount minimum, this is an absolute min problem. So to find an absolute min, what we're looking for is the edges and any critical numbers and find out which is the smallest of the amount. So I got to find an amount function. Okay, so I got to first find an amount function. And then after I find my amount function, I want to know my amount at 0. I want to know my amount at 8. And I want to know my amount at any critical number. So we also have to find critical numbers. So I'm going to find those 3 things. So let's make it an amount function. Do we know how much we started with? Yeah, 30. Right there. Okay, plus the change from 0, isn't it at 0? To, we're going to call this t. Is that okay? Because I have a t over on the other side. Of, now what's the function though? Well, the amount, isn't the amount function the rate? Isn't the amount rate function we got right here? Isn't that the derivative, a prime t? So isn't that function going to go right here? Because that's the rate of amount. So rate of amount is going to go right here. We just have a rate of amount. So I'm not going to put a prime. I'm going to put this whole thing just so you can see it. So it's going to be r of t minus d of t. Oh, I'm going to make these x's because they have to be different variables. Do you see why? Because if I'm going to be putting those t's in, don't those variables have to be different? I put a t here. So when it's done, it's going to have a t. So I kind of mess with the letters. So these x's are going to become t's. And that right there is my amount function. If I integrate this, will I get this? Sorry, if I take the derivative of this, will I get this? If I take the derivative of this, don't you get, what's the derivative of 30? Derivative of 30 is gone. And the derivative of this, doesn't the t just jump in? And doesn't it create this function? So there's my amount function. Oh, but I need to find my critical numbers. How do you find your critical numbers? Don't we have to go, oh, aren't we set the derivative, the amount rate function, no, that's not equals. Don't we want to set this equal to 0? How do we do that? 2 options. Could you move this over, graph both of these, and see where they intersect? Could you graph this and this, move it over, and see where they intersect? Or could I graph this function and see where it crosses the x-axis? Did you catch that? If I want to do this, could you graph r, add this over, and see when r and d of t intersect? On the interval 0 to 8. Remember, only 0 to 8. Or could you graph this minus this and see where it zeroes out? It's your choice. When you do that, you will get t equals 0, which is an edge, which doesn't really matter, it's an edge, which we were checking that. And you get a really big number. Not a really big, but you got to get all your decimals here. 3.271658. Do you remember that intermediate values need to be longer than 3 decimal places? So you get this big old number. So those are my two values from 0 to 8 that this is true. So guess what? It's going to be in this ugly parenthesis right here. It's going to be 3.271658. My parenthesis was not big enough. So we're taking the edges, and we're checking that critical number. Why do we not check 0? Because we're already checking it. One of these three will be your absolute min. Edges and critical numbers, check them. And now how do we find the values of each of these? Can we use this formula we just made? Can't we just use this formula? Can your calculator crunch it? If I put 0 in, aren't I going to put 0 right there? For 8. Wait, is 0 pretty easy? Is it already given? Okay. Is that okay? Isn't at 0, isn't 30? If I put 0 right there, what's the integral from 0 to 0?
1.
Nothing.
0.
30 plus nothing. Okay, good. That was an easy one. Okay, now these two, are you going to have to use a calculator to crunch it? Can you put 8 right there? Use your calculator to crunch. Can you put 3.2715658, whatever that is, and crunch it? And what do you get? Well, you get, for this one, 27.964561. In this one, you're going to get 48.543686. I'm not showing you all the work. You have to use a calculator. Plug this in for 8. Plug this ugly number in right there for t. Do the math with your calculator. These are the three answers. Which is your smallest? A of 8. So what is your absolute minimum? At 8 hours. So at 8 hours, you would have your absolute minimum. Did we miss something? Yes. I made a boo-boo.
Yeah.
What boo-boo did I make? I switched these two. Are you okay with that? I made a big boo-boo. These answers are switched. So, yeah, I made a mistake. That's a bad mistake. But so, which of these is smallest? Isn't this the smallest? So, that's kind of screwy here. Let's see. So, again, A of 8 is 48.5, and A of 3.27 is 27 point this. So this is your smallest, so that's 3.27. So my answer is, when x equals 3.271, that is when you are going to have an absolute minimum, which would be, I shouldn't have put x there, it's going to be 3.271. What units is it? Hours? So the answer is 3.271 hours. It will have its minimum. I should probably say minimum. At. I should have. Okay, I wrote that terrible. Your minimum is at 3.271 hours. Probably write that better. That would be the answer to C. Do you see how much work that took? You had to write an equation. You had to use the derivative, find the critical numbers. You had to then find values. Kind of annoying. So this last question. The pipe can hold 50 cubic feet of water. It starts at 30. Remember that? From t greater than 8, continues to flow in and out. So this next sentence, all it's saying is we can go past 8 hours. It might be longer than 8 hours for which this works. So they're extending beyond our 8-hour time frame. Write, but do not solve, an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Oh, this question needs a letter W for time. So we're going to change some letters here. So I'm going to go to D here, put it down here. Well, isn't this the function for amount? And aren't we looking for when my amount function is what? Equal to 50, because then it'd be overflowing. So aren't I just going to set this equal to 50? But where would I put W? W is the time, right? So is W going to go where? where t goes. So really all this is asking for is when 30 plus the integral from 0 to w r of, now could I put t's back in here instead of x's?
Yes.
Can I put my t's back?
Yep.
Because w and t are different.
Yep.
And then equals, what do we want to equal? 50. If I solve this, could I find w and then, yeah. Could you technically, if you took your time, integrate all this and by hand? It'd be terrible, but you could. You could find w. Does it ask for it? No. Just write it. When is my amount equal to 50? That's all it's asking for. W is now going to become the time we're looking for. And when you do integrate it, w's will pop in for the t's, and it's all good. That's this question.